All right, good afternoon, everybody. Good afternoon, my lovely people.
Good afternoon, sir.
All right, we are going to, let me see, I played me today. Latisha, I think you're writing on the screen. Tishana, you're writing on the screen now.
Sorry, sir.
That's fine, it's okay. It happens. When I'm in my class, it happens to me too. All right, good. Okay, all right, guys. We're a few in numbers, but 5 grade 1s or 4 grade 1s is better than none at all. So, you know, today's class could be very helpful. All right, so we're going to be running through the document that I sent you, right? This is the paper that we went through face to face on Saturday, yesterday. Oh, another student is coming in. So we're going to run through this paper. The back part of it, though, for my online class, I haven't started trigonometry with you guys as yet, right? I haven't started trig with you. You're all my online students, so I haven't started trig with you as yet.
I don't think so.
No,
Right.
sir, I don't think so.
Right. So that means that we can't go to question 7. Have I done measurement with you? With like volume and surface area. I think that's what we did
Yes,
last.
sir, we did that last class.
All right, so that means that we can work question 6 and then we can do yeah, so we're gonna work in from question 6 going backwards, all right? Yeah, we're gonna work from question 6 going backwards. All right, okay. Miss Gentles, I sent you the image. Did you get the image for the question that we're working today? I'm using a different screen.
Yes, sir.
Okay, all right, so you can see it. So we're working from the oh, I didn't send it to Jaden, you know. So we're working the paper from the back to the front. Oh, Jaden, do you still have the paper from yesterday's class?
Mm-hmm.
You have access to it now?
Mm-hmm.
Okay, all right. So that's what we're doing.
Okay.
All right. So let's get into it, guys. We're gonna be here until about 3:30 or minutes to 4. So let's just make very good use of the what we're doing right now. All right. So we're gonna be working the questions on the box. Let's get a move on then. All right. So at the back, starting at question 6, right? Jaden, we didn't get a chance to do the question 6 yesterday. So it's class. All right. So I'm gonna draw the diagram on the screen for what it looks like. Okay. So it says that the diagram below, which I'm gonna draw shortly, the diagram below, not drawn to scale, shows a solid glass paperweight that consists of a hemisphere mounted on top of a cylinder. The radius of the cylinder and the hemisphere is 3 centimeter, and the height is 8 centimeter. All right, so let me just draw the diagram for what this looks like. I wasn't able to put it on the actual paper. So it looks like this, guys. Give me a sec here. Still getting used to this platform, so bear with me, okay? So it looks like this. And then it has something looking like that. So that's the diagram that matches this question, right? So this is what they're calling the solid paperweight, right? Now what you're seeing here is that the I'm trying to get the color ink. Okay, so what you're seeing is that the radius, which is right here, is 3 centimeter. From here to here is 3 centimeter. Let me just make sure that's what it says, right? So the hemisphere, right? Anybody knows what a hemisphere is? A hemisphere is half of the Earth, okay? Hemisphere is half of the Earth. So the radius from here to here is And the height as suggested here is 8 centimeter. So this is the diagram that we're looking at. Okay. And you're asking us a bunch of questions about it. So the height of the paperweight is 8, and the radius of the hemisphere and also the base of the cylinder is 3 centimeter. All right. And that's the only information they gave us. And then they ask us a couple questions. Calculate the volume of the glass paperweight. That's the actual diagram that you're looking at here. And you're to calculate the surface area of the paperweight. The total surface area. I wonder if I should just use my screen. Hold on, guys. This platform is nice, but I'm not used to it. So let me see if I can use my other screen. Because then I could actually pull up the paper so that the other audience can see it. So let me see if I can use a different platform.
Yes, sir. And it's kind of hard for me because I have to be going back and forth.
Right. And that's kind of inconvenient. So let us use a different platform. All right. So hopefully this don't give us too much trouble today. I'm not doing this. Monday, mathematics worksheet day school. Let's just start a new whiteboard then. Much better, guys?
Sir, we're still
Sir, I'm still
where
seeing
we were
the
before.
old screen.
Oh, you see the old screen. Okay. I
Mhm.
think I need to stop sharing it then. All right, so
Yes.
I need to. All right. Okay. All right, tell me if you're seeing the new screen shortly.
Yes, sir.
All right, so this is the paper that we're actually working out today. All right. All right, good. So I'm going to go ahead then and resketch the diagram down here for you. So what we're looking at here is this shape here. And we are told that the height is 8. And we know that this is the hemisphere that's on top. That's basically the hemisphere. So it's a half of a ball that's mounted on top of it. All right. And we're told that the radius here, from here all the way here, is 3 centimeter. That's what we're told. All right. So that's it. That's the only information we were given. So then they went ahead now to ask us calculate the volume of the glass paperweight. Now, this particular prism, ladies and gentlemen, this particular prism, it basically consists of two different prisms. Two prisms. So this entire glass paperweight is made up of a cylinder plus a half of a sphere. That's the first thing, right? So in order for us to find the volume, even though we know the formula as we had learned in the class, that volume, let me just shift this over a little bit here so we can get some space. So even though we know from in the class that we've been teaching recently that volume is equal to area times height, we're going to have to split this into two. We're going to have to say volume 1, and then we're going to have to say volume 2. Volume 2 also equals area times height. Let me just get this down some space. So volume 2 is equal to area times height. So we're going to use this prism down here as volume 1, and then we're going to use the half here, up here, as volume 2. And then we add them together. That's the idea when you get questions like these. You're going to get multiple questions like these on your external exams. Maybe not on my end of month test, but I won't test you like that because I have to build you up like that. But for now, I took these questions from an old past paper, right? 2004, I think it was. So we're going to go ahead and we're going to break up the diagram into sections. So volume 1 represents the volume of the cylinder, and volume 2 represents the volume of the hemisphere. A hemisphere is a half of a sphere. All right. So once you know the volume of a sphere, which I didn't teach you, but you're going to learn today, the volume of a sphere is going to be the volume of a hemisphere is going to be half the volume of a sphere. All right. But let us go ahead and find what we know we can find. We already know that the volume of a cylinder is V is equal to AH. And in this case, because the cylinder has a circular base, it's going to be pi r squared. That represents the area. And you're going to times it by h. And that will give us the volume. All right. Now, they didn't specify what we should use pi as. So pi is going to be 3.14. I can use the 2 if you want to. I like using the 2. So pi is going to be 3.142 multiplied by, they told us that the radius is 3, so that's going to be 3 squared. And the height of the cylinder is going to be 8. So could somebody go ahead and process that calculation for me? Anybody? Got the answer? 3.142 times 3 squared times 8?
I'm getting 226.22.
So you're getting 226.22
Yes.
cm squared. Cm cubed, sorry. So that would be the volume.
26.8.
I'm going to double check it because we can't be. Are you using just
Sir, I got
3.14?
226.224.
Right. So you're using the 2. The person who is using the give me a second, guys. Oh, Crystal, you're not in the classroom? Crystal, are you here?
Sir, I'm not hearing you.
Oh, you guys weren't hearing me a while ago?
No, sir.
No, sir.
All right, good. Sorry, my bad. My mic was unmuted. All right, so the part that is in yellow, the 226.22 centimeter cube that we just calculated is the volume of the bottom half of that prism that you're looking at, right? That's what we calculated. Now, the second volume, volume 2, is going to be the volume of the part that's mounted on top of the cylinder, right? Now, as I said to you, that the top part, according to the question, the top part says volume, that is a hemisphere. Now, a hemisphere is a half of a sphere. A hemisphere is a half of a sphere. Now, a sphere is something that I didn't teach you in this class because, like I said, the questions that I have been doing in the extra classes are just exposing you to some critical thinking questions. So this question is from 2004, which was a while back. We no longer do sphere on the CXC exam, but don't be surprised if they bring it back. That's why I'm not afraid to help you with questions like these or to teach you questions like these. All right, so on screen here, you're looking at the formula for the volume of a cube. And generally, if they're going to give you this on your exam, they're going to give you a formula and say to you that that's the formula you should use. Now, let me just put a little red mark around it or purple or something like that so you can see that this is called the volume of a sphere, right? That's the volume of a sphere. Now, a hemisphere is a half of a sphere. So if I go ahead then and I say that a half of this, so a half multiplied by 4/3 pi r cube h, I can therefore then use the 2 to cancel itself, and the 2 into the 4 goes 2 times. So I've derived a new formula for a hemisphere. So the volume of a hemisphere is now 2/3 pi r cube h, right? Because a hemisphere is a half of a sphere. And this is the formula for finding the volume of a sphere. So hopefully that makes sense. Let's go ahead and do some calculation now. So the new volume for the top section now, that's the part that is in red, right? The volume of the sphere is now going to be 2/3 multiplied by pi, we know is 3.142. And we already know that the radius is 3, so that's going to be cube. That's going to be 3 cubes. Give me a sec. This is why I didn't want to use this platform, because this platform freezes a lot. Give me a sec. It does give me some problems, so that's why I'm trying. Don't know why this platform freezes so much. All right, so hopefully it's back. All right, so there we have it now. So the one that is in purple represents the volume of a sphere, as we've been saying. And the one at the bottom that I multiplied by a half, I multiplied it by a half because the shape, this top section right here, is a half of a sphere. So I just found a half of the formula, and then therefore that gave me 2/3 pi r cube h. Now plugging in the values, 2/3 multiplied by 3.142 times, we know that the radius, as stated earlier, was 3, so that's going to be 3 cubes, and the height of the sphere is also going to be 3 as well. That's the height of the sphere. All right. Remember that the radius of the sphere is the same thing as the height of the sphere. Let me show you where that is. The height of the sphere, the 8 is the height of the cylinder, you know. So if we have a sphere like this, look at this. Let's say we have a ball like that. That's a sphere. All right, let me just draw it a little better so you can understand what I mean, how I got my numbers. So this is the sphere. This is a O. right? And I'm going to turn it into a sphere by giving it a little 3D effect, right? And this is the sphere right here. Cool? Let me just put it into, right? That's the sphere. So that's the sphere that we're looking at, right? So the radius of the sphere, right? So if I draw a radius from here, from the center to this direction, that's the radius of the sphere. It's going to be the same thing here as well. So it's going to be the same thing here as well. Same thing here as well. And same thing here as well. So the radius of the sphere is going to be the same thing as the height of the hemisphere, if that makes sense. So that's how I got my numbers down here. All right, so go ahead and process that calculation for me. 2 divided by 3, just type exactly as I'm saying it here. 2 divides 3 times 3.14, 2 times 3 cube. That's 3 times 3 times 3 times 3 again.
I'm getting 169.67.
169.67. Somebody can confirm that, please.
I'm getting 169.66.
I know, yeah, man. That price of rest now.
Yeah,
Okay, that's fine.
I round it off.
Yeah, man. So that's going to be centimeter cube. So that's the volume of the hemisphere. So now that we have the volume of the cylinder, which is the bottom half, right? And then now we have the volume of the sphere, of the hemisphere, we can add both of them together. So we can go ahead now and add the value that we got up here. Let's just draw an arrow. So we're going to add here to this number up here. So go ahead and add those two numbers for me, and that will give us the volume of the glass paperweight.
I'm getting
Sir, I got 395.89.
395.89, yeah.
Okay. So it's 395.89 cubic centimeters. All right, so that would be the volume. All right, so hopefully you guys catch on to that. Like I said, these questions are, I haven't seen them in a while, right? But you know, we don't know what to expect from CXC, right? We don't know what you're going to send on the paper, so we have to be very, very open-minded to what potentially might come. All right, and these are just some exam structured questions that you have to open your minds to. Okay, all right, so let's move on to the next part of this question here. That part is finished. Calculate the surface area of the paperweight. Now, this is a formula that you have to actually know again. And again, remember that I have not taught this topic. So what you're seeing now is that you're seeing most of these things for the first time. All right. So now we're looking for the curved surface area of the whole entire thing here. Now remember that in our class we learned that curved surface area. Let me just write that down. Curved surface area. So remember now, guys, two shape we are finding now, you know. Two prisms, you know. We have a hemisphere at the top and we have a cylinder at the bottom. Every time you're doing the calculations, you will need to do them separately. So first we need to find the curved surface area. Don't know why I'm writing this so bad. So curve, surface, area of the cylinder. And we're going to need to find also the curved surface area of the hemisphere. So the curve, surface, area of the hemisphere. Every calculation that you will do hemisphere, you will have to do it separately because it's not one solid prism that has one solid formula. It's two separate prisms. You have a half of a sphere mounted on top of a full cylinder. So the calculation will have to be separate. Now, we have taught this in class. Curved surface area is equal to the perimeter times height. All right? That was discussed in the last class. So the curved surface area is equal to the perimeter of the cylinder times the height. Now, if we go back up to the cylinder here, I will check our diagram. We can see very clearly that the base of the cylinder is a circle. So the perimeter of a circle is the same thing as the what? Circumference of a circle. And if you can recall that the circumference of a circle is going to be 2 pi r. So let's go ahead then and structure this formula then. So curved surface area is going to be equal to the perimeter, which is 2 pi r. You times that by h. In a second, I'll come back to that formula. All right, we're going to plug in some values shortly. Now, for the curved surface area of a hemisphere, obviously, I don't teach you nothing about sphere in the class. So obviously, I wouldn't have taught you anything about curved surface area of a hemisphere. But the formula is this: the curved surface area of a hemisphere is equal to 2 pi r squared. All right? So if you remember, you remember. If you don't, I just say it go. But you're learning it now. So the curved surface area of a cylinder is 2 pi r times h, and the curved surface area of a hemisphere is 2 pi r squared. Let's plug some numbers in. 2 times pi, again, is 3.14. 2 times it by the radius, which again we know is 3. And the height of the cylinder is 8. Go ahead and process that for me, please.
Within 150.82.
How much you got?
150.82.
Somebody can confirm that?
Yes, sir.
150.82 centimeters squared. All right. Now, go ahead. Now we're going to do this one. That's going to be 2 times 3.142 times this time. Now we're going to see 3 squared this time. So it's just a slight difference, not much. This time we're going to times it by 9 as opposed to times it by 8. So it's going to be a little bit bigger than 150. Just a little bigger.
Sir, I got 56.556.
How much I got? 156?
Yes, sir.
Okay, should be a little bit bigger. Okay.
150, or just, no, it's 56.
When you multiply it,
No, sir, just 56. Yes.
56.
so how wanna get 150.82 at the top and then get. I not understand that. That means the calculation at the top is incorrect.
No, we're not multiplying by 8 down the bottom. You didn't write 8 there.
No, so at the top we were multiplying by 8, and at the bottom we were multiplying by 9.
Oh.
So it shouldn't be much of a difference. If you got
Because you didn't write it down there, maybe that's why.
Well, I don't know. It
That's
should be
why we
very
did it.
close.
Well,
So you should have typed in 2 times 3.142 times 3 times 3.
So we got like I got 56.56.
So
That
what
means
we
that-
should, so
that
we
means
should
the an-
type two.
Yeah, go ahead.
2 times that times that. Yeah.
So we should type 2 times 3.14 times 3 times 3.
Yes, correct. Yeah.
So I got the same thing.
So that means the answer at the top is wrong then, because I heard 150.82 at the top.
Excuse me, sir.
Yes, there.
I got 56.556. It's 2.3.142 times 3 times 3,
All right.
which
So
would
let's
be 9.
so let's do the one
I
at the
got
top then. All right. So let me just calculator. So at the top, we should have gotten 2 times 3.142 times, so 2 pi times the radius is 3 times the height is 8. 150. And then at the bottom now, it is 2 times 3.142 times 2 pi r h 2 pi r squared. Oh, okay. So 2 times 3.142 times 3 times 3. Okay, so it's my bad. It's my bad. I forgot that there was a height involved. Thank you. Thank you so much. My bad, guys. So 56.55. So
Okay,
56.
so
Yeah, I forgot that the 8 was involved. My bad. So 56.55. All right, so 56.55. Centimeters squared. All right, so go ahead now and add these two together now for me, ladies and gentlemen. No answer yet?
207.38.
Yeah.
And that's squared centimeters. So 207.38 squared centimeters. All right, getting a little bit of a glitch again. It's gonna happen now and again. It's fine.
Excuse me, sir.
Yes, go ahead.
I see a figure up at the top. I'm not sure
Mhm.
of 1/6 something. I didn't get that. 1/6 something another. I'm not sure
Sure.
what that is.
Yeah, when it comes up on the screen, then you let me know. So where's the 1/6? What's 1/6 you're seeing? 1/6. Oh, so that was the volume of the hemisphere. That was the volume of the top half of the diagram you're seeing. The part that is in red, the curved part.
Okay.
So,
Um,
so we
sir,
highlighted
could you,
this here. This
sir,
is
could
the
you just
volume of
allow
the.
me?
Go ahead. Go ahead.
No, I'm asking if you could just allow me to hurry up and
Yeah, man. Sure.
take
Go
it
ahead.
off, please.
Go ahead. No, man.
Okay. Thank you.
Finish. and that is squared centimeters, okay?
So sir, I see you add 169.67 to what? And I see
Oh.
at the side 395.8, and I'm not
So
seeing the top part.
So added it to 226.22.
So these are two separate
Calculations.
the V1 is a cylinder.
Right, that's correct. Right. So this
And
one
the
up here is the
V2
bottom
is a
half.
hemisphere.
Right, and it's a hemisphere, correct. So we add both of them together to get the complete volume.
So the bottom part, sorry, if this is this part up the top where you have 395, what is that? It's not an area or what?
Oh, it's
That
a
what you
volume.
can-
It's the volume.
That's
So
an area
no, it's
for
a
the
volume
both.
because it has a 3.
Oh, volume.
Right.
Oh, and the bottom part is the area.
No, man. This part is the volume of the hemisphere. This is this section right here. And this part is the volume of this section down here. So when we add them together now, we got the volume of the whole entire paperweight together.
Right, I understand that, sir. What I'm asking is the bottom part, what we just did, is that the area.
Down here.
Yeah.
Down here.
Yeah.
Right. So
Yeah.
now that part is the area now. Now we're looking for the
Okay.
curved surface area. Yeah, that's what we're looking for there.
So the curved surface area of a cylinder.
So
and
have
the
you ever
curved surface
hold
area
a
of
mug
this
in your
hemisphere.
hand before? When you hold a mug in your hand, right? It's that part of the mug that you hold in your hand. That
Yeah.
section is what we're trying to find. The area of
That would have been the cylinder.
Yeah, that would have been the area of the cylinder, the part that you're holding in your hand.
Okay.
Inside of it now, when you put the tea inside the mug, that's what we
Yes.
calculated earlier, the volume. How much liquid can hold into it. But the part that you hold with your hand, that's what we calculated at the bottom.
Okay.
Okay.
I understand.
Right. So we did it in two parts. We had to find the curved surface area of the half of the earth, half of the ball. That's the one at the top. And we had to find it. So imagine you hold a football in your hand or a tennis ball, right? You see that round feeling that you're getting when you hold the ball in your hand? That's what we're trying to find. The area of that curvature right there. So that's what we did when we found the 150.82. Sorry, that's what we did when we found the 56.55. But the one at the top now is the actual area of the mug part, the part where you're holding the cup in your hand. So when we add both of them together, we get the complete curved surface area of the whole paperweight.
Okay, sir.
All right.
Oh, sorry. Forgive me, sir. V2 equals A times H. A is what
V2?
area? I'm just looking at the volume section.
Okay. You said D2 or V2.
V2. So
right. So
A,
V2
A,
is going to be the volume of the hemisphere.
right, sir. But what is A? Area?
Oh yeah, area of the base.
Oh, so area times hemisphere. Height or
Height. Correct. Right.
height? Oh,
Right.
okay. All right, sir. Thanks.
You're most welcome. That's what the class is for, for getting clarity, So don't feel bad if you have to ask, because you're asking questions that others may want to ask, but just don't know how to ask it. So that's what the class is for. All right, let's move right along then. Now we're gonna look at finding the total surface area of the paperweight. So again, you're gonna have to find this in parts, right? You have to find this in parts. So let me just zoom this up a little bit for you here. So again, we have to find two total surface area. We have to find the total surface area of the cylinder. And we also have to find the total surface area of the hemisphere. Again, the reason why we have to do the question like this is because we do not have a solid prism that has one formula. We don't have a solid prism that has a solid formula. So we have to find it separately. Now, this was briefly explained in our last online class, right? So it's something that I may have to touch base on again before I move on. But for now, we're there, so let's just do the question. So we have total surface area is going to be equal to the surface area plus 2 times the area of the base. That's what we had discussed. Let me just write this a little better. So total surface area is going to be equal to curved surface area plus 2 times the area of the base. And this part, remember, is the total surface area of the cylindrical part. That's the bottom half. Now, the fun fact is that we already calculated the curved surface area. If you go back up here, you can see that we had calculated the curved surface area of the cylinder. See? Curved surface area of the cylinder, we had already had that answer right here as 150.82. So we're going to take that answer from up there and carry it back down here, so because we did that calculation already, 150.82. Now, this part we're going to have to calculate. That's 2 times the area of the base. And we know that for a cylinder, the base is circular. So it's going to be 2 times, we know pi r squared, pi is 3.142. And we know that the radius is going to be 3 squared. All right? So that's going to be 150.82 plus, somebody can go ahead and multiply 2 times pi times r squared for me, please.
I got 56.56.
56.56. And add those two together, what you get?
Point 38.
0.38. All right. Looks like we get that answer already. Not true. From up here, we would have gotten it up here. 207.38 or 207 point. What did we get? Right. So we had that answer partially up here. Now, this is the part that we need to add now. We need to find the total surface area of the hemisphere. And so total surface area of a hemisphere is equal to 3 pi r squared. Now, I don't want you guys to get scared, because you're probably said to yourself, oh my God, there's so many formulas, there's so much stuff. These things will come with time. And you may or may not see these. It just so happens that I met the question, I placed it on the practice paper, and we'll just work it as we go along. Some things you'll get, some things you won't get.
So we may or may not have the time.
That too. But we still there's lots of questions that are going to be on the paper that you can do. So if you just see one question that is puzzling you, that is natural. It's normal. It's normal for you to see a question on a paper that you have no idea how to do. But it's also very normal for you to see a question on a paper that you will obliterate. So you can always make up for areas that you can't get the marks for. So with this, now let us just do it. So that's 3 times pi r squared. Pi is 3.142 times the radius again is 3 squared. So go ahead and process that for me. 3 times 3.142 times 3 times 3.
That will be 84.83.
All right? Centimeter squared. So go ahead and add these two numbers together now. Those two will give you the total surface area of the whole paperweight.
And that would give 292.21.
Centimeters squared. All right. So that would be your answer for the whole entire question. You can always verify this information. So I will take you. Let me just grab Safari here for you. Give me a sec. And we can always verify this. Nothing wrong with that. So we can go here and we can type in. Give me a sec here. All right. So we can always go here and type in curve, surface, area, and total surface area of a hemisphere. Right? And when you click on go here, we're going to click on images, and it's going to give you an image of what we're looking at. So do you see? That's what we were looking at earlier. That half a thing, that half of Earth that is mounted on top of the cylinder. So you can visually see what I'm talking about here. All right, and then you can pull up this document and it will show you the formula that we have right here. There it is. Curved surface area is 2 pi r squared. Total surface area is 3 pi r squared. Okay? All right, so that verifies the calculation that we did. All right, nevertheless, let's move on, right? Some questions are going to be challenging. Some questions are going to be, pardon me? You can just type it. You can just type it in on Google, you know. Just type in curved surface area and total surface area. Okay, all right. It was just me showing you that it's there. You can always search it for yourself.
Okay.
All right, so we take care of that question to an extent, right? So let's move on to another one. Let's go up the paper. We're going to question
Sir, let me
number
get
5.
a pic. Sir, let me get a picture.
A pic?
Yes.
Sure, there it is.
Sir, go up a little more.
Up a little more? Hold on, give me a sec. There you go.
Thank you.
You're welcome. Let's move on to question number 6, which is number 5, which is something more familiar, something that I think that we definitely will be comfortable with doing. All right, and we're looking at factorization, which is a topic that we are currently doing, if we haven't done it already. Factorization. Please remind me if I haven't done it. That means if we haven't done it as yet, that means we will be doing it this week, because we are currently on algebra. All my students are on algebra. All right, so let's come here. Let's erase this and come here. All right, here we go. All right, so we are more familiar with this one now. Factorize. All right. Now, Ms. Gentles, can you confirm, have we started factorization in my class as yet? Or is that where we're supposed to be going to?
Yes, sir. We passed that.
We pass it?
Yes, sir.
Okay, good. All right, so factorization. We learned that there are 4 factoring techniques that exist in mathematics, right? 4 techniques that I've taught you. There's more, but for CSEC, there's 4. And let's just recall them, since as we're in class, we're not just going to teach, but we're going to remind you of stuff, right? So we have the HCF method. And how do we recognize the HCF method? How do we know when to use the HCF method? Is when we have repetitive terms. Is when you can see a term that's repeating itself. So when there's a common factor or a repetitive term. So if you see something that's repeating itself, repetitive, My bad, I can't spell repetitive. R-E-P, repetitive. So we know that the HCF method is required whenever there's a common factor, meaning that there's a numerical value that can divide both expressions, or we have a term that is doubling up. It's repeating itself, so a repetitive term. Now, the next method is called the grouping method. And this is the easiest one to identify. The grouping method basically has 4 terms. So basically, the key in this is to just look for the expression that has 4 terms. Most of the time, when you get a factorization question, the term that has the 4 terms, that's usually the grouping method. The difference of 2 squares, it usually has a square at the front. It has 2 terms, it has a minus sign and a square at the front. So the difference of 2 squares, it has a square term, it has a minus sign, and it only comes with 2 terms, has only 2 terms. Those are the little keys that I use. So when I start to learn too many stuff, I have to find little keys, little clues that will lead me to let me know that, okay, this expression is that technique. Has only 2 terms. I should say 2 terms, not term. So only 2 terms. And then the last one, which is quadratic. The quadratic, it has 3 terms and a square at the front. Right? So it has a square at the front. So it has a square term at the front. And it also has 3 terms. So when you get factorization, you're going to get something you get 2 of the 4, something you get 3 of the 4. So it's just based on practicing, you'll be able to pick up which one is which one. So for those who don't have those, you can screenshot that. The HCF method is a requirement when there's a common number, a common factor, or a repetitive term. The grouping method, very easy to identify. It has 4 terms. The difference of 2 squares, it has a square term, it has a minus sign, and it only has 2 terms. And for the quadratic, it has a square term and it has 3 terms. There are subtle differences between them, but there's a difference. Now, if you go back to the actual paper then, based on that information that I just gave you, look at these 3 questions here. Can anyone identify which technique matches number 1? Based on the information that you just got, can you guess which one is which one? Which technique do you think 5I is?
Difference of squares.
Very good. Difference of squares. Why? It has a square at the front, it has a minus sign, and it has 2 terms. Very good. So it's a difference of squares, Avian. I think that's Avian. That sounds like your voice. All right. So what's the rule for difference of 2 squares? Well, the rule is ensure that all the terms are raised to a power of 2. So my question to you is, which number can I square to get 4? Which number, if I raise it to the power of 2, the result will be 4?
Two.
Very good. 2. So I'm gonna change the 4 to 2 squared. X is already squared, so I can leave that one alone. And which number do I square to get 25?
5.
Very good. So now, once that's the case then, once I have everything expressed to a power of 2, the rule is we're going to open 2 brackets, and we're going to put a plus in one, and a minus in the other. And because there are two terms, there are two of every terms there, I'm going to put a 2 here and a 2 here. I'm going to put an x here and an x here. I'm going to put a 5 here and a 5 there. And that's it. That's how you factorize it. So when you're factorizing a difference of two squares, you first ensure that all the terms are raised to a power of 2. So you're not going to raise them to the power of 2, but you're going to find a number that you can raise to the power of 2 to get back the number that was there. So that's why I chose the number 2, because when I square that, I'll get 4. And I chose, well, you guys chose the number 5 because when you square it, you're going to get 25. And once you can get the situation to be reevaluated like that, then the rule is just you open two pairs of brackets and ensure that there's a plus in one of the brackets and there's a minus in the other. And ensure that each bracket contains the terms. So there's two 2's, split them up, two x's, split them up, two 5's, split them up, and you're good to go. Number 2, can you verify which technique is number 2? Based on information that I just gave you earlier. Which of those techniques would be number 2?
The grouping.
That is correct. And you can confirm this. You can confirm this because it has 4 terms. So when you have a grouping method now, what we're going to do, ladies and gentlemen, is that we're going to go, let me just rewrite it first of all. So we're going to have 6p oh, let me just write it below here. 6p minus 9ps plus 4q minus 6qs. So the rule is place them into groups of 2, small groups of 2. Then you're going to go ahead now and factorize each of those groups of 2 using the HCF method. Now look at the first red bracket. Look at the first pair of red bracket. Do you see a common number? Is there a number you think can go into 6 and into 9?
3.
Very good. And is there a letter that's repeating itself?
P.
Very good. Open the bracket. Now, how many times can 3 go into 6?
2 times.
Right? And the P that was right beside the 6, it's now on the outside, so I can't put it back on the inside. How many times can 3 go into 9?
3 times.
Very good. And the P that is beside the 9, it's already on the outside, so what's left on the inside?
1.
The S.
Oh, the F. Oh.
Yeah, because the P that's beside the 9ps, it's already
I
on the
think
outside.
that look like P square.
Oh, no, it's PS.
Oh.
All right. On the second bracket now, is there a common factor between 4 and 6? Is there a number that can go into 4 and 6?
2.
Very good. And is there a letter that's repeating itself?
Q.
Very good. Take that out. Open the bracket. How many times can 2 go into 4?
2 times.
And the Q that's beside the 4Q is already on the outside, so I can't put anything back on the inside. How many times can 2 go into 6?
3 times.
Very good. And the Q that's beside the 6QS, the Q is on the outside, so what's left?
The S.
Very good. Now you can confirm that your answer is indeed correct, because if you notice that there is one bracket there that seems to be repeating itself, not true? And that bracket is going to be 2 minus 3s. Now if you're doing this question and you're at this stage, you know you're on the right track. If you end up with 2 different things in the bracket, you did something wrong. So now that these 2 brackets that are repeating themselves is the same, I can just use one of them. So the answer is going to be 2 minus 3s in one bracket, because both of them is the same, so I can just use one. And then the remaining terms are going to be what? 3 plus 2q. And that's going to be your factored answer. 2 minus 3s, open bracket, 3p plus 2q. All right, and that takes care of example number 2. All right, now remember that there's 2 techniques left, you know. There's no way Csec is going to give you the same technique twice. That wouldn't be an exam. So that means if you get 3 questions like what we have there, and you already used 2 of the techniques, can you guess which one of the other 2 techniques is number 3?
The quadratic.
That is correct, the quadratic, right? And you can confirm this because according to the clues I gave you about a quadratic, the quadratic has a term, a square term at the front, and it has 3 terms. So although they look quite similar, there are subtle differences that will help you to identify which technique is which one. All right. Now, Ms. Gentles, can you confirm for me? If you can look in your notes and tell me. I'm trying to remember if I taught this. I'm supposed to either be getting there or I'm there already.
No, sir. No, sir.
So I haven't
were
taught
at
this as yet.
No, we just do the HCS and
Right.
the grouping.
And the grouping. So that means this week, this class this week, which is coming,
Yes.
we're going to be doing the difference of 2 squares and the quadratic, right? But you're gonna get a little premature teaching about it now. All right. All right. So let's just erase here. So for the quadratic, then here is the technique. Most of my groups are just starting this topic, so it's no big deal. All right. So for the quadratic, step 1 is to multiply the first and the last term together. That's the rule. Multiply the first term or the first number with the last number. Now, in this case, when I multiply 3 times -4, I'm going to get -12. That's step 1. 3 times -4 is -12. What I'm going to do then is that I'm going to split up the 12 into smaller numbers. 12 is so big, right? Doesn't look like a big number, but it is. So we're going to break it down into smaller pairs. I want some numbers that will multiply, give me 12, but it must be smaller than 12. So I can try 1 times 12 will give me 12. I can try 2 times 6, that will also give me 12. And I can also try 3 times 4, which is also going to give me 12. But having to list them is the easy part. Choosing the correct one can sometimes be a challenge. So how do I choose? I have 3 pairs. How do I know which one is the correct one? The one that you choose is going to be the one that's able to give you back the term in the middle, which is the 4. So I need to choose the pair that if I add it or maybe if I subtract it, it will produce the term in the middle. The number that is in the middle is 4. Now my question to you is, looking at those pairs that are to the side, which of those combinations will potentially produce a 4 if I add or subtract them? I have 1 and 12, 2 and 6, 3 and 4. Which of those combinations could potentially produce a 4 if I add or subtract it?
2 and 6.
2 and 6.
2 and 6. So that's my choice. All right. So now that I've made my choice, I'm now going to keep this guy in the game. So this 3x squared remains in the game. But this middle guy right here, we're going to substitute him. Right? He's been in the game for too long. So we're going to kick him away and put those 2 terms right in the center. So I'm going to have plus 6x squared. Sorry, plus 6x. Pardon me, take out the square. Plus 6x minus 2x. And keep the last guy in the game. Minus 4. So that last guy is in the game. Right? So basically what we do here is that we keep this guy in the game. And we keep this guy in the game. But that middle guy right here is replaced by the factors that I chose over here. All right? Remember, this is premature teaching, so I'm just showing you this one. In this class this week, you'll get a better understanding of what we're looking at. Okay? Now, which technique did we earlier discuss that when you see that amount of terms, it represents that technique? We have 4 terms in front of us. Which method is required here?
Grouping.
Very good, grouping. So we're going to go ahead and place it into groups of 2. First bracket. Do you see a number that's common and a letter that's repeating? Let me know which one. Look at the first 2 terms. Is there a number that can go into
3.
X and 3? Say the number first though. 3 and X.
Yeah, 3x.
Right, good, very good. Take up that. Now, how many x's was in the first term? We have 3x squared. How much x was there at first? It's 3x squared, you know, so the number is telling you how much x is there.
2x is 2.
You put 1 on the outside, so how much is left on the inside?
1.
Very good. All right, and then 3 goes into 6 how many times?
2 times.
2 times, and the x that was beside the 6x is on the outside already, so we close the bracket. Now, is there a number that's repeating itself on the right? Or is there a number that's common to both numbers?
2.
2. Is the x repeating itself?
No.
No.
So we don't take it out. You leave it alone because it's not common. You only take it out if it's repeating itself. So open the bracket. Now, if I remove the minus 2 from here, what is left when I remove the minus 2?
X minus
Very good.
x.
All right. And then negative into negative. So this negative divides this negative and gives us positive here. And 2 into 4 goes what?
2
2 times. So how do we know that we're on the right track based on the knowledge that we gained earlier? Both brackets are the same. If that's the same, then these 2 can be merged and they can become 1. So that's x plus 2. And then the remaining terms is going to be 3x and minus 2. 3x and minus 2. All right? So that is how you answer that particular question then. All right, so we can make a note of that. That takes care of the factorization aspect of this paper. All right? We can move to the fraction part. Working out that fraction problem there. Take off what you need to take off. Like I said, ladies and gentlemen, for most of you who are here, you have not learned this. Maybe like 2 persons in my class right now that learned this physically. But for you guys, you haven't been exposed. So this week, you'll get much more clarity on the steps to go forward. Okay? So we're going to go back to fundamentals now, right? Because we have some nice questions on the paper now. One of the things that I'm going to teach you throughout the course of the next 3 months is exam strategy, right? A lot of you guys are going to go in there and feeling flustered. How am I going to remember this? How am I going to remember that? There's so many formulas to study. I'm not motivated. I don't really like math. It's just too much. There are strategies that you can use to pass the exam. There are persons that go into the exam with something specific in their minds, and that alone them focus on. You're focusing on a set amount of questions that you're targeting. The only thing that can derail them is if they focus on an entire topic and that topic doesn't come. But majority of the time, we normally teach you the topics that are very common. So as we go closer and closer to the exam date, I'll give you more and more exam strategies. So don't worry about learning everything because you cannot. It's a lot. There's a lot that we have done and there's a lot that we haven't done. So can you imagine the things that are coming? There's much work to be done. But you cannot remember everything. So we have to just try. It's the ones that we know so we can do. For example, this one here. I don't expect anybody to get this question incorrect, because this is a sure 3 marks on the exam. All right? So let's see how this one is worked. Back to fundamentals, the first 2 weeks of class when you met me. 2¼ times 4/5, all divided by 3/5 minus a half. What's the rule for multiplication? Well, first of all, what's the rule for fraction? When you see a mixed fraction, you should convert it, correct? Yes or no?
Yes, sir.
All right, so we're going to go ahead and say 4 times 2 is 8 plus 1 is what? 9/4 multiplied by what? 4/5. What's the rule for What's the rule when you're multiplying two fractions? If you saw that, what would you do?
Cancel.
You'd cancel. Very good. So you'd cancel the 4 here, and then your answer for the top section would have been what? 9/5. There's nothing else to do. 9/5. Now for the bottom section, we end up with what? 3/5 minus 1/2. What's the rule for when you're adding or subtracting fractions?
You find the LCM.
That is very good, Miss Gentles. So therefore then, how do we find the LCM of 5 and 2? What's the lowest number that 5 and 2 can go into?
10.
Very good. And we say what? 5 into 10 goes how many times?
2 times.
Put that at the top. And 2 into 10 goes what?
5.
Very good. Now 3 times 2 is?
6.
And 1 times 5 is?
5.
So we end up there nicely with an answer of 1/10. So notice now that we have 2 answers. One at the top, which is 9/5, and one at the bottom, which is 1/10. Now this bar right here, hopefully remember that means division. So that means you're going to take the answer that we got for the top, which is 9/5, and we're going to divide it by the answer we got for the bottom, which is 1/10. What is the rule for division? We eat it every weekend. Some of us.
You keep, you change, and you flip.
You keep, you change, and you flip. So you keep the first, you change the sign, and you flip the last one, 10/1. All right, now we're back to multiplication. So you told me the rule earlier for multiplication. Remind me again. What's the rule for multiplication?
Cancel.
So that's 5 into itself 1 time and 5 into 10, 2. So the answer is going to be 9 times 2 is 18 over 1 times 1 is 1, which is equal to 18. So the answer for that question is 18. Okay? So it's questions like those that when you get them, they normally send shockwaves, because if you find yourself buck shuffling on these, especially when you get close, because you have whole part time same way. We have whole of 3 months, February, March, and April. So we have whole part time can catch up. But I just don't want you guys to get certain questions on the exam that you are supposed to get right. The tough ones then we can understand. But the easy ones then, don't get those wrong plus the tough ones then. Makes no sense. Okay? All right? So that clears up that. Any question? I don't think you guys have any questions on that. So take a screenshot and do your thing, and let's move on to question number 4. All right, so we have a very interesting. Yes, go ahead.
Sir, remember
dear.
you said that you're going to send us a study guide for the test on
Oh yeah, man.
Thursday.
Right, I will. I'm contemplating if I should really use my class to do the test again. I want to send you as a worksheet. That's what I'm tempted to do. Because at the end of the day, I don't want to just use my class time. I want to test you to see how you manage under pressure or under a time constraint. So I'm ifing and butting whether I should really use my class time. But I'm going to run a poll. I'm going to see what the audience says. Right? So I'm going to run a poll in the group, and then I'm going to find out what persons are leaning towards. Do they want to try it on the exam?
Or, sir, if possible,
Yeah.
we could come in on a Saturday and you do it face to face. Could use one of the other room or something. I'm just saying that,
yeah. So right. So I'm gonna when I'm creating the poll, I'm gonna put that as an option. Do you rather to come in face to face, and put yourself under an exam condition, or would you want it as a worksheet to be uploaded? Because what I'll do is that I would upload the document, right? And then I'll give you a time frame to get it done. So the moment I upload it, I will give you 2 hours to get it done. But I will give you on a different day other than our class day. So let's say that we don't have class on a Thursday. I would upload it Tuesday at 7 and then tell us you need to finish it up by, say, 9:30. So that would still be exam because you'll still be under pressure. You wouldn't get a day to finish it though. So I'm gonna find out from them. All right, I'm gonna find out from them and hear what they have to say. All right, in the meantime, let's look at the other one. All right, so I have a very interesting question, and this question is today I caught my students overthinking this question. All right, so it says here, I caught them overthinking yesterday. I was like, wow, okay then. It says that the figure shown below, I'm going to draw it shortly, guys. The figure shown below, which is not drawn to scale, represents the cross-section of 2 circular pizzas, both of which are equally thick and they contain the same toppings. The question that they're asking you is that, is a medium pizza twice as large as a small pizza? And whatever decision you make, you're supposed to use calculations to support your decision. Now, here's the diagram that was drawn for the students. Here's the diagram that matches that question. So what was on the exam paper was this. There was a circle here, which them say represents a pizza, and it was a slightly bigger one, like that, right? So there was 2 sizes pizza. One of the pizza had a diameter of 15, and the other pizza had a diameter of 30. And as them say, is that the pizzas both have the same toppings and they were equally thick. So that was the diagram that represents the information that we just read, right? Now it said that this is called the small and this is called the medium. And the question was, is a medium pizza twice as large as a small one? That was the question. Now let me get some opinions. What do you guys think? Do you think, just by looking at it, do you think that a medium pizza is twice as large as the small one? If you were to guess, what would you do? If you go to Domino's or Pizza Hut or Caesar
Well,
Palace,
based off the information that is there, it look like it's 2 times.
it looks like it's 2 times,
But
right?
I don't think in really it really is. So.
You know questions, man. When they normally ask you questions like those, usually the answer is no, but you have to support it with some calculation. So, I'm not seeing the chats, so if you're talking in the chats, I don't know. Zahine, what do you think? Do you think it's larger? Do you think it's twice as large?
Sir, I agree with what the recent person said. It looks like it, but I'm not sure.
You're not sure?
Mm-mm.
Avian, what do you think? You think it's twice as large? If you had to make a decision and stick with it, life or death, what would you choose? Oh, she probably had to work or something. All right. I'm not sure if Stacey is in here. I think she said that she was going to leave early. Latisha, what do you think? You think it's twice as large?
No, sir.
You don't think so?
I don't think so. No, sir.
Okay. That's
But
depending
on the answer that they give,
yeah.
you probably have to support the answer, but I don't think so.
You don't think so? So everybody's answer is It looks like
Well, based
you're not
off the
sure.
fact that that one is half the size, then it would probably be. I
Is
was
it
just
half
looking
the
at it.
size
One
though?
is 15 centimeter and the other is 30.
Mm-hmm.
So that looks like
So the
215
temptation is to
would be
say that it's
30.
twice. Not true.
Right. That's it.
But then
So,
you know you're not supposed to be tempted with mathematics questions. All right, so let's figure it out now. We don't know, Let us figure it out. In order for us to figure this out, ladies and gentlemen, we have to consult the area of the pizza. So you'd have to find the area of the small pizza. So we're going to call this AS, area of small, and we're going to call this AM, area of medium. Now, regardless of the size of the pizza, ladies and gentlemen, the pizza is a circle. So if the circle big like the earth, or the circle small like one little hole, the formula still remains the same. So the area of the small, according to the area of a circle, is pi r squared. And the area of the large is also going to be pi r squared. Because what makes the difference in the area is not the formula, it's the diameter. All right, so pi, as usual, I like using 3.142. If you guys want to leave out the 2, that's up to you. Right, for me, I think the 2 just gives me more accuracy, but it will not change the price of rice. So let's go ahead then and type this number in. Pi is 3.142. What's the radius of the small pizza?
7.5.
Excellent. I caught my students doing this yesterday. They told me that the radius was 15. So I taught them out, like I lead them astray, and then I ask them an important question. You know what I let them do yesterday? I work out the whole entire question, I make them write it off and tell them say it right, and then 2 minutes after that, I tell them say it wrong. I make them mess up them book.
Oh
Yep.
my gosh.
Of course I did. Yes, I know I'm cruel. I did that because they need to concentrate on what they're doing. You're supposed to catch me and tell me, sir, you're talking foolishness. Because if I draw a line on the circle and I wrote 15, you're supposed to be paying attention to say, no, ma, hold on, wait. The line that runs across the middle of the circle is the diameter. So if sir asked me for the radius, how am I telling him 15? So that's what I did yesterday. I'm sorry. I'm evil, but I did that. Go ahead and calculate that for me, please.
176.74
centimeters squared. Now go ahead and
Yes.
consult the area now for the medium pizza. Let us see what happens.
Oh.
So that's going to be 3.142 times the radius of this is 15 now, squared. Go ahead and calculate that for me.
And that is 706.95.
All right, now, so we want to compare the size. So I need to know how much of this can fit into that. How much of this can fit into this? So I'm going to divide the area of the large pizza by the area of the small. So that's going to be 706. It's going to be 706.
Divided by
0.95 divided by the small one. I want to know how much of the small one can hold into the medium one. What number did you get?
So that's 3.99.
Round it up.
4.
Good. So what's your conclusion? Your answer is what?
It's 4.
No, the answer is no, it's not twice as large. It is what?
2 times.
4 times as large.
4 times as
as
large.
large.
Yeah.
So your answer is the answer to the question over here, right? We go back to the question. The question says what? Is a medium pizza twice as large as a small? Your answer is no, it's not. It is 4 times as large. And the calculation I just did is what supports your answer. And that's it. So those are the critical thinking questions that Csec sends every year. They're not going to send you a circle with a radius and say find the area of the circle. No, they're going to connect the question with something realistic that will require mathematical application that people don't do on a regular basis. Can you imagine going to Domino's or going to Pizza Hut and you're having your meal, and when you look crossway the table, there's a young lady with a ruler and a pencil measuring the pizza to find out which one is big or small? Wouldn't that be a weird sight? It would be a weird sight. So this is just an example to show you that mathematics is applied even when you're having a nice meal where you're like, yeah, man, this is applied. All right, next question says, here's a biconditional statement. It says that a medium pizza is cut into 3 equal parts, and each slice is sold for $15.95. However, the small pizza is sold for $12.95. Which is the better buy? And based on your decision, use calculations to support it. Now again, I'm going to ask you, based on what you think. If you have a medium pizza and you cut it into 3 equal parts, you don't know if the parts them big or small, you know. You just don't see the 3 parts them equal. And you see a small pizza for $12.95. Everybody and anybody, well, everybody, I want to hear your opinion. Starting with nobody specific. Latisha can start. What would you do? Would you buy 1 slice of the medium pizza, or would you buy a small pizza? Make a decision. What would you do? 1 slice.
Sir, can you repeat, please? Some night was in my background.
Right, so I'm saying that based on the situation that's presented here, we have a medium pizza that was cut into 3 equal parts. We don't know if it's big or small. We just say 3 equal parts, and each slice is being sold for $15.95. But you have a small pizza, right, that's been sold for $12.95. Would you buy 1 slice of a medium, or would you buy the small pizza? Which one do you think is a better buy? And tell me why you said that. What would you do? Anybody can start, you know. Miss Gentles, you can tell me what would you do. Zahini, you can tell me.
I would just buy the small pizza.
You'd buy the small pizza. All right, I accept that.
Yeah.
Zahini, what would you do?
I think I would buy the medium pizza.
You'd buy 1 slice of the medium pizza.
Yes, sir. I mean, if it's medium, that means it's you get a bigger slice, you know?
But look on the money we have pay for it, you pay a little bit more, you know? So you're sure that you find a decision? I'm not say you're wrong, you know. I'm just saying. What do you think is the better
Okay,
buy?
so I switch to the small pizza.
You'd buy a small pizza instead, not true?
Yes, sir.
All right. Miss Gentles, what would you do?
Well, based off the fact that the medium pizza is 4 times the size of the small one, so it will probably, even though you pay a bit more, but it will probably be bigger than the small one. So I'll go with a slice.
You take your $15.95 and buy 1 slice of a medium pizza as opposed to buying a whole entire small pizza?
Yes, because the slice bigger than the small one.
How you know that?
Because based off the calculation that was done.
Okay. Who else is in my class? Because I don't remember who else I let in the class, you know. Jaden, you love pizza. I asked you. No, I'm not asking you. Yesterday, you said the solution. You say. I'm not asking you anything.
Remember me telling someone
to
to go down there?
You went down there?
Remember I told you I would go if I wanted to figure it out?
Oh, okay.
The class finish?
No.
Oh my God.
Tishana, what would you do?
What time class finish?
When we finish.
What?
When we finish.
Why am I going to miss something now?
Sir,
Yes, dear. Yes, Tishana, what would you do?
I would buy the small pizza based on the fact that the small pizza is less than the the medium one, the price,
Mm-hmm.
and is the same amount you will be getting if you decide to buy one of the slice of the medium pizza.
You think so? Just by observation, that's what you think?
Yeah.
Remember, arrive on spot, you have to make the decision, So if you go Domino's, you'll be like, okay, do I buy a small pizza?
It is less. The price is less, but I would say it's the same amount, the same size you would get if you buy a slice from the medium pizza.
All right. I don't know. Avian is here, but I'm not sure if she's hearing us. Krista, what would you do? No, Crystal's in the class. She might not
Yes,
want
sir.
to.
I'm here, and I would
What would
buy
you do? What would you do if you had to make a decision without no maths, just looking at the price and the size?
Well,
And
if it was that I did not see the calculation, I would go with the small. But looking at the calculation, I would go with the slice because even though you're paying a little bit more, it's still larger than the small.
all right, and that's based off observation, right?
Right.
All right, Lisa Gay, you want to join us? You want to share your opinion? What would you do?
They're just looking at it and a small whole pizza.
Mm-hmm.
I would go for the small one, whole pizza, because you can share it up any which way. You can share it up like a piece or whatever to give to share.
Right.
In opposed to as just a slice.
Just a slice.
Have a slice for that, yeah.
I can pick up that some of you guys are actually buying this pizza based off hunger. Based off hunger. I can tell you, you guys are not really checking it. I mean, a few of you are right and a few of you are wrong. We're going to prove it shortly, right? Because I hear mixed results. I hear some persons that is small, like Lisa gets she buy a small so she can share it up. And then somebody saying a slice. So some persons is looking at the numbers and some persons is actually buying this thing based off of hunger. So let's see what the math says now. Because math cannot wrong. So here's what we're going to figure it out. Right? I'm coming. I need to refresh the page. Give me a sec. We're going to figure it out, man. All right. So based on as somebody's saying, based on the price, that's what they would do. And in the moment, no one really cares. It just in the moment, you just go to make a decision. Whether you're wrong or right. But the question is, which is the better buy? Better buy means in terms of the price for your pay, and it also have to be based on the quantity of the item that you're getting. So if you're paying a lesser price, right, for more quantity, that's a better buy, not true? If you're paying a lesser price, for the same quantity, that's a better buy. So less price, higher quantity, or less price, same quantity is a better buy. The only way it's not a better buy is if you pay the same price for a lesser quantity. So let us see what we can do here. So to do this then, right, we're going to try to check what is the price that you would pay for a certain amount of the small pizza. Now we already know, let's write down some stuff here. I'm gonna finish the class shortly, guys. Come on, it's Sunday, so we have to go. So here, let's zoom it up. All right, good. So let us write down what we know. We are told that the actual small pizza costs $12.95. And the large pizza, or one slice of the large pizza, so one slice is equal to $15.95. Now, if one slice is $15.95, we need to find the area of one slice. Because we already know the area for the large pizza, So let us find the area of one slice. So area of one slice is equal to 706.95 divided by 3. Somebody tell me what that answer is. This value that you're going to tell me now is going to be the value that represents one slice of the medium pizza.
$235.65.
235.65. So basically what this is saying is that you're paying $15.95 for 235 square centimeters of pizza. That's what it's saying. Let me just write this better. How much you said, Miss Lisa gave? 235.65?
Yes, sir.
Right. So basically what this calculation is saying is that you're paying $15.95 for 235.65 square centimeters of pizza. And you're paying $12.95 for 176. Look at the difference in the area and look at the difference in the price. Subtract those two numbers for me now. 235.65 minus 176.74. Let us see what the difference in the amount, because we're checking the quantity now. How much more pizza are you getting when you eat one slice versus a whole entire small pizza?
58.91.
So 58.91. So you're getting 58.91 more pizza on a slice than what you're getting on a whole entire small pizza. And you're only paying, what's the difference in the price? Subtract these two, 15.95. All of this, is just your justification, When you're writing these things down, it's just your justification. So what's the difference in the price now? How much more money are you paying?
$3.
$3.
So you're paying $3 extra to get a whole entire 58.91 square centimeters more pizza. You're paying $3 more, not true? All right. Now look at this now. What we're going to do now, we're going to finalize everything now, Right? We're on one more calculation now. So now we know that we can confirm that one slice of the medium pizza has an area of 58.91 more. One slice, has 58.91 more than a whole entire small pizza. And in order for you to access that 58.91 more pizza, you only have to pay $3 more. Not true? So now, what we're going to do is that we're going to take the 176 here. Look at this now, We're going to take the 176 here, which is the area of the whole entire small pizza. And we're going to divide it by the amount extra that we're going to get. How much more of this? How much of this area will go into the large one? So 58.91. Divide those two numbers for me and tell me what you get. If you get a number that is higher than 3, the natural tendency is going to be you'd have to buy a one slice. So how much you got when you did that?
3.
Exactly. Exactly 3?
3.
3.00 some
3 point
I
how much?
get
1 over
exactly
something.
3.00.
So basically 3.
Yes, sir.
Yes.
So
Basically 3.
So basically 3. So when I'm looking at this, it's a better buy. It doesn't matter which one you do. Because you're getting the same value. Realize? So
Yes, sir.
you're getting the same value, so none of them is a better buy. So if you buy a medium pizza or you buy one slice of large pizza, you're getting the same quantity. The price makes no difference. So it's an even decision. That's what mathematics is saying. So that would be your conclusion based on the mathematics. All right, so none of you guys are wrong. Well, all of you are wrong. But then you have some person gonna make decision off of hunger. Right now, me now buy. Myself, some people look at it now. Me now buy piece of nothing and pay more money when I can actually buy a whole and pay less. Some people do that. You know what? Me I just buy 2 small one then. That's what you're gonna look at it like. Because remember that mathematics is not applied in reality now. When the persons are spending your money, them just look on it like they look at it from a different point of view. But based on what we've done here in this question, your decision would have to be that there is none of them is a better buy. Either it's the both of them is a good buy. Okay, you're getting the same amount. All right. All right, that is it. So I worked a few questions with you. Right. The time that we have on Sundays is not enough to work a whole paper, but we still have the practice paper them. That's important. So we can always work them on our own. Or you can work them and send them to me and I'll do them and I'll look at them. So you have these questions up here to do. These are some nice ones as well. You can attempt those. Here's a worded question number 1. We have another algebra question, which I don't think you guys have gotten to this stage as yet. So I don't think you guys will be able to work number 1, A, B. Well, you can work 1A and B, but I don't think you can work. Sorry, you can work 1A, but I don't think you guys are able to do B and C as yet. I know you can work one. I know you can work the C part down here. This one. I know you can work this one because I taught it in class. And you haven't learned this one as yet. So even if I wanted to go on with the class, to do an extra class that with a topic that I haven't taught you as yet, it's kind of going to make the class feel like a show rather than a teaching class. All right, so let's see here. Let me see what one you can do. You can try this one. This one's a very interesting one as well. This is very interesting. That one here with the recipe, I would love to hear what your natural opinion would be without my intervention. All right. And I know that you guys, well, this one is kind of tricky still, you know. This one is kind of tricky. You might need my help for this one. All right, but that's it. That's it. All right. So, the recording will be posted as soon as I get the time to do so. You can always watch it over if you need to. All right. And as usual, I'll see you guys tomorrow at 7. And then hopefully all being well, I'll see you guys again next week for a different set of practice questions. All right. Have a good one. Be blessed. Bye-bye.
Bye, sir.
Bye.
Bye.
Bye, everyone.
Bye, sir. Bye, sir.
All right. Take care. Bye-bye.